Hey everyone, welcome back. Have you ever wondered what would happen if the moon suddenly disappeared? It's more than just losing a beautiful sight in the night sky. It would have unimaginable consequences on Earth. From major changes in ocean tides to shifts in Earth's rotation, climate, and even our biological rhythms, the disappearance of the moon could change life as we know it forever. In today's video, we'll explore the science behind this hypothetical scenario, backed by data and facts, and uncover just how much we depend on the moon. Get ready to dive into this mind-bending thought experiment. Let's get started. The moon's origin and its connection to Earth. To understand how crucial the moon is, we need to start with its origin. The moon formed about 4.5 billion years ago, likely from a giant impact between Earth and a Mars-sized body called Theia. This collision sent debris into orbit around Earth, which eventually coalesced into the moon. It's not just a companion in our night sky, it's a part of Earth's history, evolution, and stability. The moon has always played a key role in Earth's development. Scientists believe that its formation contributed to Earth's current rotation speed, which stabilized after the collision. Before the moon, Earth might have rotated much faster, with days lasting only 6 to 8 hours. The presence of the moon helped slow down Earth's rotation, giving us the 24-hour day we're used to. This deceleration has continued over billions of years, and if the moon suddenly vanished, the effects would be profound. In fact, the moon's role goes beyond just its gravitational influence. It's also a key factor in stabilizing Earth's axial tilt, keeping it at a steady 23.5 degrees. This tilt is responsible for the seasons we experience, as it determines how much sunlight different parts of the Earth receive throughout the year. But what if the moon were to disappear tomorrow? How would it change our world? Let's break down the science. Tides, a world of oceanic disruption. The most immediate and noticeable impact of the moon's disappearance would be on the ocean tides. The moon's gravity pulls on Earth, creating a bulge in the ocean's water, which we perceive as high and low tides. Currently, about 60% of tidal forces are due to the moon, while the remaining 40% comes from the sun. Without the moon, the sun would still influence the tides, but they would be significantly weaker, about 1/3 of their current strength. Imagine the effects on ecosystems that have evolved around these tidal cycles. Coastal areas would be among the first to feel the impact. Estuaries, where rivers meet the sea, rely on strong tidal flows to mix fresh and salt water. This mixing is crucial for the breeding of fish and other marine life. Without it, many species could fail to reproduce, leading to declines in populations of fish, crabs, and even larger marine mammals that depend on these environments. Consider places like the Bay of Fundy in Canada, home to some of the highest tides on Earth, with water levels that can rise and fall by up to 16 meters, 52 feet. Without the moon, those tides would drop to just 5 meters, 16 feet, causing dramatic changes in the shoreline and potentially turning tidal flats into dry land. This could have severe economic consequences, affecting fisheries, tourism, and even local weather patterns. Moreover, weaker tides mean less oceanic mixing. Ocean mixing is vital for bringing nutrients from the deep sea up to the surface, where they nourish plankton, the foundation of the marine food web. With less mixing, plankton populations could plummet, and the entire marine food chain would suffer. It's estimated that plankton produce about 50% of the world's oxygen, so a decline in their numbers could even impact the air we breathe. Beyond the oceans, reduced tides would have a significant impact on river deltas around the world. River deltas, like the Mississippi Delta in the United States or the Nile Delta in Egypt, depend on tidal forces to regulate the flow of sediment and nutrients. A change in tidal strength could alter sediment distribution, potentially leading to increased erosion and the loss of fertile land. This could severely impact agriculture in these regions, where millions of people rely on the rich soils of river deltas for their livelihoods. Another consideration is the impact on sea level rise. While the moon's disappearance wouldn't directly cause a rise in sea levels, the changes in tidal dynamics could exacerbate the effects of climate change. As glaciers and ice caps continue to melt, the redistribution of water in a world with weaker tides could make coastal flooding more unpredictable and severe. Countries like Bangladesh and island nations in the Pacific could face even greater challenges as they battle rising waters. Earth's rotation, shorter days and faster spins. The moon's gravitational influence doesn't just create tides, it also helps to slow down Earth's rotation. This is due to a process called tidal friction, where the Moon's gravity pulls on the Earth's oceans, creating a slight drag that gradually slows our planet's spin. Currently, Earth's rotation slows by about 1.7 milliseconds per century because of this. If the Moon were to disappear, this process would reverse, and Earth's rotation would gradually speed up. While the change wouldn't be immediate, over millions of years, we could see days shorten from 24 hours to around 15 or 16 hours. Imagine living in a world where the sun rises and sets within a much shorter span. Our entire perception of time would shift. Faster rotation would also mean a stronger Coriolis effect, which influences wind and ocean currents. A more intense Coriolis effect could result in faster jet streams, more intense hurricanes, and a general increase in atmospheric turbulence. Cities like Miami and Tokyo, already prone to extreme weather, could face even more powerful storms, challenging their infrastructure and disaster preparedness. Moreover, a faster spinning Earth could change the shape of our planet. Currently, Earth is slightly flattened at the poles and bulging at the equator due to its rotation. An increase in rotation speed would exaggerate this shape, potentially causing changes in sea levels as water shifts toward the equator. Coastal regions worldwide could see rising waters, leading to displacement and increased flooding risks. In addition to this, the faster rotation would have an impact on the distribution of wind patterns globally. The jet streams, which currently influence weather patterns across the continents, could become more erratic, leading to greater unpredictability in weather systems. This could result in prolonged droughts in some areas, while others might experience relentless storms. The agricultural systems, designed around relatively stable seasonal patterns, would be hard-pressed to adapt, potentially leading to food shortages. Climate instability, a chaotic world. One of the most significant effects of losing the Moon would be the destabilization of Earth's axial tilt. The Moon's gravitational pull helps keep our axial tilt stable at around 23.5 degrees, giving us predictable seasons. Without the Moon, Earth's axial tilt could wobble between 10 and 45 degrees over time. What would that mean for our climate? Let's break it down with a concrete example. Imagine that Earth's tilt shifts from 23.5 degrees to 40 degrees. Regions that are currently temperate, like Europe and North America, could suddenly experience extreme seasonal shifts. Summers could become scorching hot, while winters could become bitterly cold. It's estimated that a change of just 5 degrees in axial tilt could be enough to trigger an ice age. On the flip side, if the tilt decreased to 10 degrees, we would experience much milder seasons, with little variation between summer and winter. Tropical regions might become unbearably hot year-round, while polar regions could thaw, leading to the melting of ice caps and a rise in sea levels. This could potentially displace millions of people living in coastal areas, creating a new wave of climate refugees and straining global resources. There's evidence to suggest that extreme axial tilt variations could have played a role in past extinction events. A wobbling axis could create rapid climate changes, challenging the ability of plants and animals to adapt. If this happened today, we might see mass extinctions of species that are unable to cope with rapid temperature shifts, disrupting ecosystems worldwide. Consider Antarctica, which currently remains locked in ice year-round. With a significant shift in axial tilt, Antarctica could thaw, releasing vast amounts of fresh water into the oceans. This could alter ocean currents like the Atlantic Meridional Overturning Circulation, AMOC, which plays a critical role in regulating temperatures in the Northern Hemisphere. If the AMOC slows down, Europe could experience colder conditions, even as other parts of the world become warmer. The disappearance of moonlight impacts on nocturnal life. The Moon is more than just a beautiful sight in the night sky. It plays a crucial role in providing light during the nighttime, especially during full moons when it can illuminate landscapes with up to 0.25 lux of brightness. This might seem insignificant compared to daylight, but for nocturnal animals, moonlight can be the difference between life and death. For example, sea turtles rely on moonlight to find their way back to the ocean after hatching. Without the Moon's guidance, more hatchlings might become disoriented, leading to higher mortality rates. Predators like lions and hyenas also hunt more effectively during bright, moonlit nights. A moonless world could force these animals to alter their hunting habits, possibly leading to increased competition and changes in predator-prey dynamics. The loss of moonlight would also impact plants and insects that rely on lunar cycles. Some flowering plants use moonlight to time their blooming, which in turn attracts pollinators like moths and bats. A world without moonlight could disrupt these relationships, potentially leading to declines in certain plant species and the insects that depend on them. This could have a cascading effect through ecosystems, altering food webs and affecting species far removed from the initial impact. For humans, the loss of moonlight could also affect our behavior. Studies have shown that people sleep less deeply during full moons due to increased light levels. A world without moonlight could lead to longer, more restful sleep, but at what cost? The cultural and psychological implications of losing this ancient companion in the sky could change the way we perceive the world, possibly increasing rates of depression and anxiety as we adjust to a darker world. In certain cultures, lunar cycles play a significant role in agriculture. Farmers in regions like India and China have traditionally used the phases of the moon to determine the best times for planting and harvesting crops. With no moon to guide them, these age-old practices would become obsolete, forcing farmers to rely solely on other indicators of weather and climate, which may not be as reliable in a changing world. The moon's influence on Earth's magnetic field. Here's something you might not know. The moon plays a subtle yet significant role in maintaining Earth's magnetic field. Our magnetic field, generated by the movement of molten iron in the Earth's outer core, acts as a protective shield against harmful solar and cosmic radiation. The moon's gravitational influence helps stabilize this movement, keeping our magnetic field consistent. Without the moon, some scientists believe that the core could become more turbulent, potentially leading to a weaker magnetic field. A weaker magnetic field could allow more radiation to reach Earth's surface, which could increase rates of skin cancer and other health issues over time. It could also disrupt electronic systems, GPS, and satellites, affecting everything from navigation to global communications. Comparing Earth to Mars gives us a glimpse into what might happen. Mars has a weak magnetic field, and as a result, its atmosphere has been stripped away by solar wind over billions of years, making it a cold and barren world. While Earth's thicker atmosphere would protect us in the short term, a prolonged weakening of our magnetic shield could lead to gradual atmospheric loss, making Earth less hospitable to life over millions of years. Beyond health effects, a weaker magnetic field could also mean more spectacular displays of auroras, as solar particles interact more directly with Earth's atmosphere. But while the northern and southern lights might become more common, the increased radiation would pose a serious risk to astronauts in low Earth orbit, making space exploration more dangerous than ever before. Cultural and evolutionary impacts. The moon has been more than a celestial body. It has shaped human culture, religion, and even our biological evolution. Ancient civilizations like the Mayans, Egyptians, and Babylonians all worshipped the moon, using its cycles to create calendars and guide agricultural practices. If the moon were to disappear, it would create a cultural void, impacting religions that observe lunar cycles, like Islam, which uses the lunar calendar to determine the timing of Ramadan. Beyond culture, some scientists believe that the stable climate provided by the moon's presence might have played a role in the evolution of complex life on Earth, including humans. The steady climate allowed for the development of agriculture, which in turn enabled the rise of civilizations. Without the moon's stabilizing influence, it's possible that life on Earth might have taken a very different path, or perhaps not have developed at all. Moreover, the moon has been a stepping stone for our dreams of space exploration. The Apollo missions were a testament to human curiosity and the desire to explore beyond our world. With new missions planned, such as NASA's Artemis program aiming to establish a sustainable presence on the moon is seen as a gateway to Mars and beyond. If the moon disappeared, our space ambitions would be severely hindered, and we'd need to rethink how we explore the cosmos. How could the moon disappear? Unlikely but intriguing scenarios. While the disappearance of the moon is a hypothetical scenario, it's worth exploring how it might happen. One possibility is a massive asteroid impact that could shatter the moon into pieces. This might create a debris field that could even threaten Earth with an intense meteor shower, potentially impacting our atmosphere and causing global cooling. Another possibility is that the moon could continue drifting away from Earth. Right now, the moon is moving about 3.8 centimeters away from us each year. While it would take billions of years for the moon to escape Earth's gravity entirely, an accelerated drift could cause changes in tides and other processes long before the moon fully departs. The idea of advanced alien technology removing the moon or a cosmic event like a rogue planet's gravity pulling it away is the stuff of science fiction, but it's a fascinating thought experiment. Such scenarios allow us to appreciate the delicate balance that keeps our solar system in order and remind us of how interconnected we are with the cosmos. Would humanity survive? Adapting to a moonless world. So, could humans survive in a world without the moon? The answer is a cautious yes, but it would require massive adaptation. To deal with changing climates, we might need to develop new agricultural practices, possibly using indoor farming or genetically modified crops that can withstand extreme conditions. We might also need to build artificial structures or satellites that mimic some of the moon's functions, such as stabilizing our planet's tilt or creating artificial tides. Protecting ourselves from increased radiation could involve new advances in shielding technologies for homes and cities, as well as medical breakthroughs to combat radiation-related diseases. In terms of societal adaptation, we'd need to rethink everything from our timekeeping systems to cultural practices, adjusting to a new reality where the moon is no longer part of our lives. The loss of the moon would be a challenge unlike any we've faced before, but if there's one thing humanity has shown, it's our ability to adapt and innovate in the face of change. Whether through technological advances or new ways of living, we would find ways to survive and thrive, even in a world that has lost its ancient companion in the sky. The moon's disappearance may be a hypothetical scenario, but it serves as a reminder of how interconnected our universe truly is. The moon is more than just a rock in space, it's a stabilizer, a life support system, and a source of endless wonder. By imagining a world without it, we can better appreciate the delicate balance that allows life on Earth to flourish. So, what do you think? Could humanity rise to the challenge of a moonless world, or would the changes be too much to handle? Let us know in the comments below. And if you enjoyed this exploration into the mysteries of our universe, don't forget to like, subscribe, and hit that notification bell. Thanks for watching, and until next time, keep looking up, because you never know what you might find.